so pedigrees. Okay, so what is a pedigree? Okay, so a pedigree is defined as, and by the way, this little symbol means definition, defined as a family history that shows how a trait is inherited over several generations. Oh, I'm spelling several wrong. Sorry guys, several generations. Alright, so first things first, let me give you a key. Okay, so let's just talk boys here. Alright, so a square is a boy all day, every day. So if I shade that square in, then that is a male that is affected with whatever the trait is, affected male. Now, usually this is like a genetic disorder or something like that, but I mean, it doesn't have to be. We could do widow's peak or hitchhiker's thumb or whatever. Can you roll your tongue? Can you not? Whatever. All right. And then if it is not shaded, then it's unaffected. So this is a male that is unaffected by the trait. So this is a male that doesn't have it. In other words, phenotypically, what you can see, this individual does not have the trait. All right, so, but occasionally, but not often, occasionally you get a square and it's half shaded. Usually you're not going to get that. You're not going to be able to see that because usually that's giving you the answer to the question. So usually we don't half shade. But if you do see a half shade, this is a male that is a carrier or it's heterozygous. So carrier or heterozygous for the trait. Okay? Alright, now let's go over to females. Guess what? Females are circles. Okay? And if I shade the circle in, then it is an affected female. Okay? If I don't shade it in, then it's an unaffected female. And again, if I half shade, then it's a heterozygote or carrier female. Again, you are rarely going to see the half shaded. So if you do, click your heels, because that makes it a whole lot easier. So no more guesswork involved. Alright, now let's talk about the chart itself. Alright, so starting here, it doesn't matter if you put male first or female first, nobody cares. Alright, so let's say I've got this individual, and obviously that's a male. And then I've got this individual. This line here indicates that these two individuals have mated. So that indicates a mating. Okay, so that indicates mating. Alright, now I'm going to draw another line going down. This line indicates offspring, so children, in other words. Okay, so here are all the children, and not to say there's a whole lot of children, I just want to give myself some space. So there's a daughter, and then here's a son, okay, and then here's another daughter, and then here's another son, and then let's go ahead and give them another daughter. They had a lot of kids. Cool. Alright, so let's say that only, or at least so far, only this daughter has gotten married. So we're going to mate her with another male. Cool. Now, obviously, they've had children, so let's go ahead and give them some children. So let's give them 2 sons. And so that is basically how you would set it up. Now, on the side here, you'd put in Roman numerals the generations. Here's generation 1, here's generation 2, and then here's generation 3. So looking at this child here is the grandson of this individual. So it goes grandpa, mom and dad, grandsons. Okay, so that's how that would go. Alright, so let's say we're talking about albinism, and albinism is a recessive disorder. It is a recessive disorder. Okay, so let's say that dad here is an albino. Well, the only genotype dad can have, since it's recessive, is dad can only be this. Now, mom over here, or grandma, we don't know. Because grandma can either be this, or grandma could be this. So we don't know. Miss Johnson's not nice enough to half shade it in for you to know. Alright, so ultimately, now we got to figure out, what about the kids? What about the kids? Alright, so let's say that this child is an albino. So we know this child has to be that. So now let's think about if this child is little a, that means that the child inherited a little a from dad and a little a from mom. So dad and mom must be heterozygotes, because the child has 2 little a's, and there's only one way that could have happened, is if they got one from mom and the other one from dad. That having been said, we still don't know if grandma here is big A, little a. We still have no idea. Okay? Because either way, either cross I do gives me an opportunity to have a child that's big A, little a. Let me show you. So let's say I crossed, let's say the mother was big A, little a, and dad is little a, little a. So I got 50% chance of having a heterozygous child there. Okay? Now let's do the OR over here. Now I have 100% chance of having a heterozygous child. Okay, so in both scenarios, either heterozygous mom or homozygous A mom, I still get an opportunity to have a child that is a heterozygote. So let's do this, and let's make it a little bit easier. This child here, I'll shade her in. That child there is an albino, which means that she's little a, because that's the only way that she could be an albino. So then I can go back to that question, what's the mother got to be? Well, what's the only opportunity, what's the only chance of getting an albino child in this situation? The only chance is that the mother is a heterozygote, because if the mother was a homozygous dominant, then the only way, the only children she'd have would be all heterozygotes, and they'd all be normal. Okay? So that means that mom is the heterozygous condition. So mom is therefore half shaded. And so that's the way you have to kind of figure these things out. Okay? That kind of leads me to what's called a test cross. Essentially, we just did that. Trying to figure out which one of these is the genotype for an individual that's displaying the dominant trait. Because you can't just look at that person and say, this person, oh, you're heterozygous. Oh, you're homozygous. It looks the same. So you'd end up having to do what's called a test cross. And that is a test cross, where you cross a homozygous recessive to figure out what the dominant trait individual genotype is. Is it heterozygous or is it homozygous dominant? Okay? All right, so now you're going to go practice some more on pedigrees.